All right, let's go ahead and get started. Hi, everybody. How are you all doing today? How many of you all are nervous about the midterm? Why? How many of y'all thought it was hard? How many of y'all thought it was easy? How many of you thought it was unfair? Anybody? You fail? Anyone else? No, just kidding. How many of you thought it was reasonably fair? How many of you found a topic on there that wasn't on the sheet that I gave you? Okay. When I grade, I normally do it in 2 passes. I go through once and I mark everything that's wrong. Then I go through again and I assign points the second time. I find if I try to assign points the first time, then I end up doing it wrong and I have to go back and just do it anyway, because what will happen is I'll write something bad into the question and then I'll find out that I was grading and it was my mistake rather than yours. So I've made the first pass through. They're okay. There's only 1 perfect score in the class, which meant that it was about hard enough from my point of view. And I will have them for you on Thursday. Okay? Any questions that came up as a result of the midterm that you'd like me to address now? Okay, and that's everything that'll be on the final exam. Just kidding. Any questions about the midterm right now? All right. Project 3 is posted. You should be working on it. It's due like a week from today. A week from Thursday, right? Okay. Any questions about it? It's due whenever it's due on the sheet. I hope it's not today. Yes. We will, actually I'm going to go a little bit more over vectors and give you some stuff that's relevant to the project today. I just wanted to address any questions first. Other questions about the project? I don't know. The other instructor is handling the rubric. He normally sends something out when it is, so I don't think it is. Yes, for some definition of soon. Within our lifetimes, hopefully. Other questions? Yes, sir. That's not a question? All right. So we went over vectors before the midterm last week. We're going to go ahead and revisit them, and I will give you some more specific examples that relate to the project so that you will have some more specific examples that relate to the project. How's that sound? All right, so last time we looked at a bunch of different things about vectors. We looked at how to create a vector. We looked at how to create a vector of a certain size. We looked at how to do things to all the elements of the vectors. And we're going to look at how to load a vector from file. We'll revisit these relatively quickly. What is a vector? Yes? It's a container that you can put things in. The things we put in there, can they be different or do they all have to be the same? In one vector, they all have to be the same type, right? We haven't yet seen a way to put disjoint types together and put them into a vector. All right, so when we have a vector has to be a type. What library do we use to get vectors? The vector library. How do we create a vector? How do we create an int? Yeah, so we create a vector, we just say vector. How do we tell it what's going to be in there? Yep, we have these angle brackets with the type inside. So, just for fun, let's say that it's going to be a character, okay? Instead of an integer, we'll see something different. This is the type. It's a vector of character. It has a name, which we'll just call char_vec for character vector. And we're done. How big is this vector? It's 0. It's 0 big, which also means that it is empty. And we have methods to tell how big they are. What method do we use to tell how big a vector is? Dot size. You use the vector name dot size with parentheses. That is the method that will tell you how the vector is. What method do we use to tell if the vector is empty or not? Dot empty. So we can use a couple of different methods to see what's in there. If we wanted to create a vector of a certain size, how would we do this? So we'll create another vector of characters, and we'll call it char_vec 2 for the second character vector, and say we wanted to make a certain number of spaces in here. Tell you what, let's do this better. Instead of character vector, let's just call this COSC-051 grades. How's that? And there's 47 students in this class, so how big do we want to make this vector? Okay, how many of y'all think 46? Because they're numbered 0 to 46, right? How many of you think 47? There's 47 of them numbered 0 through 46, so there's 46 plus the slot for 0 makes 47, right? That is consistent. You'll see that over and over again in computer languages. There is a reason behind it that we may or may not get to in this class, but computer scientists typically start counting at 0. So the 0th, first, second, all the way up to 46. So if we want 47, we just put 47 in there. What values are inside this vector when we create it? Yeah, we saw for an ints that it put zeros in there, right? But have we seen what it does for characters? We don't. How do we look and see what's inside there? Yeah. Exactly. So one of the things that we're going to do when we do this over and over and over again is we do things for all the elements in the vector, one after the other. And the typical way we do this is using a for loop. Okay? So if we wanted to print out, for example, what was in there, we could say for int I equals 0, I less than grades.size, I plus plus, and in here we can print something out, so we can say cout, sorry, I meant to make that COSC-051 grades. Okay, so for less than the size of the vector, we can print something out. Now, how do we access individual elements of the vector? We can put square brackets with the index inside, or we can use a method which is the .at. They are equivalent. Okay? .at and square brackets like this are equivalent. Most people will use square brackets. That's the more typical notation. So, what we have now is an algorithm. It does a few things. It creates an empty vector that we never use again. It creates a vector of grades for 47 grades for everyone in this class. And we've created it, we don't really know what's in there, so now we're going to print out. So we start at the 0th place. As long as we're less than the size, which in this case is 47, but we're numbered 0 through 46, so we're going to access the 0 through 46th elements in the array. We print out what's in that particular slot. Okay, everybody with me? Who's with me? Who's against me? Okay, just checking. So let's go ahead and compile this. I've named this one Vector2 because we did a vector program last class, which I haven't posted to Blackboard yet. Did I? Maybe I did, but I'll post this one too. We'll compile it. It compiles nicely without error. So let's run it. And remember, this is going to print out 47 times what the default for a character is if you don't initialize it. And it is something like a space or a tab or a return or something like that. We can't really tell the difference, but it's something blank. Right. Does that make sense? All right. How many of you all at the end of the semester would like to receive a blank grade? Anybody? I should know better than to ask rhetorical questions that have a funny answer. All right. So instead, what we'd like to do is initialize these grades to something. Like, what initial value would you like all these grades to have? A. All right. So just like we wanted to access something to print, we can do a for loop, and it's essentially exactly the same as the other one. And this time what we're going to do is we're going to set each slot to have a particular value. How do we do this? Yeah, how do we assign? Yep, equals. We can just use equals. And what are we going to set this equal to? Yes. Are you happy? How many of y'all want A's? I wish I could give you all A's. It would make my job easier. Okay, so here's our vector. Here's our algorithm now. We create an empty vector, which we never use again. We create this vector of grades, which we're going to use, that has initial slots for everybody in the class. We loop from the 0th position, because we're using I as an indicator of the position, as long as it's less than the size. Size is 47, so it will go from 0 to 46. And for each one, we set it equal to A. When we're done with that, now we're going to print it out, again, from the 0th to the 46th position. When we print it out, it should display a whole bunch of A's. So let's see if it works. It compiled cleanly. Let's run it. And there are all the A's. So often, when you create a vector, and when you want to initialize a vector, you need to loop over the vector and explicitly set each element to what you want it to be. Does that make sense? When you create a vector, you can create it with a certain number of spaces. You have to set those to what you want them to be. All right. Everybody good so far? All right, so the other thing that we might want to do is load a vector from a file. Right? So we open a file, we're going to read everything out of the file, and we're going to insert it into the vector. You all are quiet today. Is this super familiar because you studied it for the exam? You just quiet? Subdued? Terrified? You know, it would be really funny if you all ever got together just to mess with me and decided you were never going to say anything in class all day. I would probably go nuts by the end of the day, if that's not what you're doing now. All right, so if we're going to load things from a file, we have to do all the stuff that we did before for a file. So we can say if stream input file. We can say input file dot open. And you know what? I messed up. I created my example, and I meant for this to be ints, not cars, so I'm going to change that up there. Sorry about that. So I'm going to change character vec that we weren't using to int vec. And we'll open this file called vecdata.txt. Now, here's vecdata.txt. It is a bunch of integers that I just randomly typed in. So we're just reading a bunch of integers in and storing them into a vector. Okay. So we open it. We check to make sure it opened correctly. Yes? Okay, so here's the deal. When I first taught you about initializing variables, I told you you had to put them all at the top. That was a lie. Remember I told you I was going to lie to you? I'm going to come clean about my lie. You can actually do it anywhere you want. Now, for politeness sake, when you write your code, it's better to put them at the top because then people know where to look for them. Does that make sense? But you can actually just slap them down anywhere you want. Yes, you have to declare them before you can use them. But you can declare them anywhere for the most part. Okay. All right, sorry. I should have come clean on that earlier. This is the lazy computer geek way of doing it, which is not the best way. Yes? Yep. We'll get to the horizontal case. We'll get to the horizontal case later. And in fact, for this, it's not going to matter whether they're horizontal or in a column. And the reason is because just like cin grabs things one at a time, yeah, it'll either break on a space or on a return. So we can do it both ways. After we do this, we'll do it the other way, and I'll show you it works exactly the same. Okay. So to answer the questions, you can declare variables anywhere you want. The language will let you do that, but as a convention, it's better if you declare them at the top. For examples, I'm being lazy and just doing it where I need it. Yes, sir. Okay, so again, what I'm showing you here is everything that a vector is capable of doing. I cannot tell you offhand like everything you're ever going to need to use it for. There are situations where we'll start with an empty vector and we'll just add things to it. There are situations where we'll start with a vector that has a certain number of elements that we need to initialize. There are times we need to load from a file. So remember, what I'm showing you here is more the capabilities of the vector, so that when you encounter an algorithm that you're working with that you need some sort of functionality, if not in the very dim recesses of your mind, then at least in your notes, you'll remember it's there, or you'll remember to go look it up online. Hopefully you remember what a vector is, right? Does that make sense? So I'm just more showing you what it can do. In the next example we'll go through, I'll show you how we're actually going to use a few of these things for our project a little bit more as it relates, okay? Yes. You can. You can use pushback to add things. You can use pop back, which will take things off. And there's also a method called resize that will resize the vector to a certain size if you need to do it. Okay. And there's clear, which will empty the vector completely. So you can change the size of a vector once you've declared it. All right, so if we don't have our input file, we'll just exit. I'm just not even going to print a message, which might come back to bite me. Okay, so we've opened an input file. If all goes well, let's compile. I'll just check and make sure it's going well. Okay, it seems to be going well. Okay, this is pretty standard. This is our little formula for opening a file. Everybody familiar with this? Yes? Now, how do we read in from the file into a vector? All right, so one way we can do something like int input while input file into input feeds into input. What we're saying is declare a temporary integer. As long as we can, take integers out of the input file and put them into this temporary variable named input. Yes?
So, when you're initializing a variable,
Mm-hmm.
what's the plus of giving it an initial value?
Okay, so there's a couple of different things. The plus of giving an initial value is that it keeps you from screwing up later and working with the thing when it doesn't have an initial value. Now, I created something here and I didn't initialize it. It's good practice to. But I'm pretty confident here that because I declared it here and I'm just going to use it in the next line, I'm not going to forget to initialize it in the meantime. Okay? So for variables that I'm using for things that I'm using for some sort of temporary thing, I tend not to initialize. If it's something that I'm using as a real variable that I'm going to be doing calculations on, I try to initialize it. Yes? Yes. I'll show you. Well, ask me that question after I'm done with this, and I'll demonstrate that there are things we have to initialize. How's that? All right, other questions? So we don't have to initialize this because we're just going to start taking stuff in. And if we don't take stuff in, if there's nothing in the file, we'll never use this variable, and it won't matter that it's not initialized. All right, so here, and remember we were working with the grades vector before, now we're working with this int vec now, all right? So we say int vec dot push back input. What does the pushback method do? Yeah. Yep, it'll expand the vector to make it one slot bigger, and it'll take whatever you have there and put it on that bottom slot. Does that make sense? So it makes the vector bigger at the bottom, not at the top, and it pushes things onto the bottom of the vector. Everybody good with that? All right, so we've put everything into this vector when we've done. This should read everything into the vector. And we should be good. Yes? Okay. Yes, I am mixing up my two examples here, and I probably shouldn't. This vector of grades was the one that we knew how big it would have to be. And this vector of ints, we just made an empty vector, and we're going to put things into it. So pedagogically, I am screwing up right now. I should give you two separate examples. Do you want me to do that? How many of you care? How many of you don't? Here's what I'm going to do. I'm going to save this, and then I'm just going to strip all this other stuff out of grades out. How's that? There. Now we have a cleaner example. Oh, and I just overwrote the old one. Hang on a second. All right. So now we have a cleaner example. I just stripped out the other vector. Now we're working with an empty vector, the infec. We're going to open a file, and we're going to put all the numbers from the file into the vector. Is that clearer? How many of y'all thought that helped? How many of you thought it hurt? How many of you had no clue what I was doing? Come on, you can admit it. Okay, so I just created another example. I simplified this. Our algorithm is now to create a vector, open a file, read numbers from the file, and put it into the vector. Okay. Questions? I just made a big change, so I want to make sure that everybody's on board before I go on. Exactly. I just stripped out the character vector with the fixed size and the grades. And I put that in another example, which I'll also post to Blackboard, so they'll both be on there. Yes? You might. Probably, I mean, here's the example is probably not. Like, I can't think of a time that you're going to have a vector of fixed size where you suddenly have to add more to it. That seems unlikely. But it's within the capabilities of the language, and I want to show you that it's possible. Most of the time, if you're using pushback, you're starting with an empty vector like we're doing here. Okay. Does that make sense? All right, so we read a bunch of numbers in. How do we print out what got read in? How do we print out stuff that's in a vector? We have a for loop because we have to access every single element one at a time. So this is like almost hard-coded into my fingers by now because I've typed it so many times in my life, except I mess it up when I'm talking about it. Okay, so let me put some comments in here. This part loads values from the file. This part accesses each element to print it. So here's our algorithm. Load a vector from a file, load values, access each element, and print it, and then we should be done. Everybody on board? Okay. Let's just see if this works or not. I will compile it. I will run it. Sorry, I changed the program, so it's actually vector 3. Now I'll run it. And it prints out the numbers that we read from the file. Okay? So these are the basic pieces that we're going to need. Now, I had two questions I was going along. The first was, given that this is our data file, does it make a difference whether it's in a row or column? So I just changed it from a row to column. Is it going to make any difference? How many of y'all think it'll be different? How many of y'all think it will not? So when we're using this input operator, angle, angle, when we're using angle, angle right here, it does not care whether it's a space or whether it's a return, right? If you tell it to look for an int, it will say, hey, here's a number. It will start right here, and it will say, hey, here's a number. I'm going to find as many things together that make an integer as I can. And what can it make out of an integer? Is a 1 part of an integer? Is a 0 part of an integer? Is a space part of an integer? It is not. So it's not going to make any difference for us whether or not, I didn't even need to recompile it. It doesn't make any difference. It still is able to extract the data from the file. That was one of the questions answered. The other question I had asked, yes? Yep. This one right here, the stream insertion extraction operator is its formal name, but nobody ever calls it that. Yep. Then cin is going to break. The angle operator is going to break, just like we saw before. If we put a character in the middle here, what we can expect to see, what we can expect to see is we're only going to get the first few numbers out because I don't have to recompile, because it breaks. And once it breaks silently, and once it's broken, the program continues to run, but it no longer takes input. All right. Everybody still good? Yes? No? Okay, so the other question I had is, when is it important to initialize things? Let's say that we want to add up and all the values in the vector. Like we want to add up all these values and average them. How do we add them up and average them? So we have here a vector, we've loaded it, we have a vector that's full of numbers. How do we add all those numbers together? Yeah? Yep. So, if we want to add everything up, gosh, I'm just cut and paste this, that'll be easier. If we want to add everything up, we need, again, one of these loops that goes through and accesses everything. And what we have to do is say, okay, total plus equals I. So I declared a variable total that we're going to add everything to. We loop. Oh, gosh. Sorry, that was totally wrong, wasn't it? Int sub I. So what I say is we declare a variable total. This is going to carry the running total of everything that's in that file. We're going to iterate over every element in there, and each element we're going to add to the total. Does that make sense? What is going to go horribly awry here? Horribly awry. Yes, sir. What value does total have right now? We don't know. Now, there's a reasonable chance it's going to be 0, but let's just see what we're starting with. All right, so we're going to print out total before we use it. And it would help if I put total in there, wouldn't it? So we're going to print out total before we use it. And this is an answer to your question, why do we initialize variables? Because things can go horribly wrong. So I'll compile it. I will run it. All right, so this time it said, oh, sorry, I got to take the bad input out of our file here. Now what's going to happen is every time we run it, come on, we're getting zeros. It's not always going to be 0, I swear to God. There's actually a logic. There's a logic behind what this value is. And I don't want to have to go into it because it would be explaining the inner workings of the machine. But some days this is not total. And I swear if I just run it over and over again long enough, eventually it'll not be total. Is it still 0? Man. So total happens to be 0 this time, but I swear to God, it's not always going to be that way. And if you don't initialize the variables that you have right here, you know, it's funny because when I show you how things are going to go right, they go wrong, and when I try to show you how to go wrong, they go right. So you have to initialize a counter like this, okay? All of the types of variable, if you do not declare the variable, you have no guarantee of what's going to be in there. Absolutely none. Yeah. The computer will happily let you compile with things that are uninitialized. Well, sometimes. So let me just show you one more thing about the compiler. I didn't show you this before, but we will now. How about that? So if I do this compile, it works. But if I put -wall, this generates additional compiler warnings. And I don't know if it's going to catch the fact that our variable is undeclared or not. Yeah, it does. Okay. So you can tell the compiler to give you more warnings if you want. And in fact, some places where they code, they use this, and the standard is that there can be no compiler warnings either. It's just that some of the things that it throws up are a little bit more complex than you need for this class. So, like right now it's comparing between a signed and unsigned integer in lines 25, which I think is this loop right here. Because the integer vector is always going to have a positive side, and we said int, so if we wanted to get rid of the warning, we'd have to type unsigned int. It's just more complex than we need. Notice that it didn't warn you about the uninitialized value, though, which kind of sucks. So. All right. Okay, so if we want to total something, that is how we do it. We have to set a total, loop everything, add it all up, and we compile it and run it. It should tell us correctly what the total was. I said the total of all that is 376, which seems correct to me. All right. This was like kind of our fast review of everything we did in class before. Do you all see the relevance to the project we're working on yet? A little bit? All right, let's stand up, shake yourself, take a break for 1 minute. When we come back, we're going to do one more example that's a little bit more project-oriented. Oh man, really? Here. Shouldn't just eat candy all the time. Question or candy? All right. What? Oh, sorry. All right, so let's go back and get started again. What we're going to do now is a small example that should be closer to what we're working on the project to show you how we're going to do things, okay? In particular, the thing I'm trying to demonstrate to you here is how you are going to need to store the data inside your project. How you're going to store the data inside the project, all right? I'm going to work with a smaller example than the one we're doing in the project because, you know, it's class and we don't have 2 weeks to do it. We have whatever time we have here. So let's say we have a file that looks like this. We have some people and we're keeping track of their age, their name, their age, and their shoe size. What type is their name? It is a string. What type is age? And what type is shoe size? It's a float. So they have different floats. Could we store for each person, for each individual in this file, could we store all their data in a single vector? Be gone. That's 2 weeks from now. All right. Right now, we don't have a way of combining different types of data into the same thing, right? It exists, and we're going to get there, I swear. It's just we haven't shown it to you yet, all right? So if we're going to store all this information, we have to think of a different way to store it. We cannot store things together going across, but how about going up and down? Sam is a name. What type is it? Wally's a name. What type is it? So are all these things going to be a string? Could we put all of them together into a vector? We could. Same with age. Every age is going to be an int. Could we put all those ages together into a vector? How about shoe size? They're all going to be a floating point number. Could we put them all together into the same vector? We could. Okay. So what we can end up with, what we would end up with is 3 separate vectors. One would be called name. One would be called age. And one would be called something like shoe size, right? These are going to be strings. These are going to be ints. These are going to be floats. if we want to get the data for one particular person out of there, how do we do that? Exactly. So what's going to happen is if this one is Sam, for example, and Sam is what, 19, and has a shoe size, wait, 18 and a half? That would be big. 8 and a half, right? All of Sam's data is represented by the fact that they are the first one in each vector. See where this is going? How many different types of data do you have in the project? Like 7 or 8 columns, aren't there? So you need a bunch of different vectors, but each subject is going to be represented by essentially that row across all of the data. Does that help? Everybody with me? Haven't you already got that far? All right. So let's take a look. Here's my program, person.cc, and here's what our algorithm needs to do, okay? What we're going to try and do here is we're going to create vectors to hold this person data that we were just looking at. We're going to load the data from a file, and we're going to do some computation over the vector, and we're going to be able to search and find something in there. All right? So these are what we want to be able to do. Does all this look relatively familiar to you from the project requirements? All right, we're not going to write functions to do this. We're just going to write it into code, and we'll do it. So tell me, what vectors do we need to hold the data? We need a vector that we're going to call name, and what does it hold in it? A string. And how big does it have to be? We don't know, right? We're reading out of a file. How many things can a file have in it? Essentially an infinite number as far as we're concerned. Then we need another vector, and we're going to call this one age, and what's this one going to hold? An int, because we count age by integers, at least once you reach the age of about 2. And then we need a vector of what? We can just use floats, and we'll call this shoe, just for shoe size. How many things do these, so here we are, we've declared these 3 vectors. How many things are in these vectors? 0. They are empty. They are 0 big. All right, now we need to load data from the file. This should be relatively straightforward. ifstream input file. I'm just going to cheat and do this all at once. So yes, thank you. Sorry, I thought I set that up before class, but I guess not. All right, so we've opened it. And now what do we do? Let's just get the compiler line set up and see what's going on here. All right, so it's compiling without error now, which we like. That means our code so far is correct. So we've declared 3 vectors, a string and a float, of name, age, and shoe. We have opened the input file. If we had a message, it would say, if something went wrong, it would say you suck, but it didn't say that, so nothing went wrong. And now we need to load data in from the file into our. So what do we have to do to take care of this data? Yes, sir. No, I don't think we need to switch. Yep. Okay, so we need a while loop. Where did it go? Ah, there we go. So we need a while loop. Okay, So we're going to declare a few variables. We'll declare a string in name for incoming name, an int in age for incoming an age, and a float in shoe for incoming shoe size. So, input file. We do. I was going to wonder if anybody was going to catch that. So, here's the structure of our data. Our data is structured so that it is in nice, neat fields, right? If it's in nice, neat fields that always are going to be the same type and in the same order, we can use the angle-angle operator. However, we have this problem up here. What is that thing? The header line. We have to get rid of the header line, right? So how do you all get rid of the header line? You should have done this for your project already. String trash. I just call it, this is what I do. Get line. Okay. So because we've called getLine once on the input file, it should strip away that string. And remember, when we're doing input, it's like there's a magic pointer or magic mark that's going along and keeping track of where we are. So once we've used that getLine to get rid of the first line, we are ready to start reading right where Sam is. All right. So we've got rid of the header. Now, what we're able to do now is say in name, in that while loop, in name, angle, angle, in age, angle, angle, in shoe. And what this is going to say is we're reading from the input file, and we're looking for something that's a name, that's a string, an age, and a shoe, which is going to, a string, an int, and a float. And because of the way our data is structured, we have a string with a space, an int with a space, and a float with a space. So it will be able to read those successfully. All right. Does that make sense? And because we're using the angle-angle, it breaks on spaces and splits that data up. Yes, sir? Well, if you read data the way that I'm showing you to do it here, you don't need it. Okay. There is a method that you can call an input string called .eof that tells if the file is done or not. You know, if you're looking in the book or if you're looking at other examples might read files that way. This is, you know, like if we're speaking English and you wanted to tell me that I'm stupid, right? How would you tell me that I'm stupid? All right, somebody else come up with something else. That's the only way to do it? Come on, I'm an idiot, I'm a moron, right? What are the Monty Python insults? My mother smelled of elderberries, right? We can go on all sorts of things. And so there's a whole bunch of ways to do the same thing. Just like there's different ways to do the same thing in English, we can do the same thing in C++. I'm just showing you one way. This way will consistently work as long as the data is formatted correctly. Okay? Everybody good with this? All right. So now we should be reading these things in. Now that we've read them in, though, we have to put them somewhere. Each one of these temporary values has to go somewhere. How do we do that? And where do we put them? We put them into the vectors. So name, we do dot push back in name. Right? Age, we do dot push back in age. Shoe, we do dot push back in shoe. Now when this loop completes, the vector should have read in all of the different values from the file. And because we're doing this in a consistent order, the data should be that the data about the name about the person, the age about the person, and the shoe about the person should all be in the same slot in each vector. Does that make sense? Nope, return is white space. So Yeah, we could. If we just kept doing angles and we had enough variables, we could have input name 1 and then input name 2, and we could do it 2 at a time. The danger of that is it doesn't work if there is an odd number of people in the file. It only works cleanly if there's an even number of people, otherwise it'll hang. And if you didn't understand that question, no worries. Okay. Everybody good so far? So at this point, we've declared vectors and we've filled all of our vectors up with data from this file right here. So now we have a vector, if it runs correctly, which it should, we now have a vector of strings, which are name, a vector of numbers, which are ages, and a vector of floating point numbers, which are shoe sizes. Got it? All right. Do we want to test and make sure that that's actually the case? Do you want to print all these things out? How many of y'all want to print them out? Great. Typically when I'm writing programs like this, I actually do print them out just to make sure that I'm reading things correctly. So we'll do some computation. We'll print out vectors to check. How do we print out stuff that's in a vector? How do we print out stuff that's in a vector? All right, everybody, when I say how do we print out stuff in a vector, I want everybody to say for loop. Ready? How do we print out stuff in a vector? How do we access every single element in a vector to do computation on it? Thank you. So, for int I equals 0, I less than names dot size. Oh, wait a minute. We have a problem though. We have 3 different vectors, but we can only check the size of one inside the loop. Is that a problem? Why is it not a problem? Because all of these vectors should be the same size, right? They should all be the same size. Because we're reading things row by row, every time we read a row and push things into the vector, they are all going to be the same size. So it does not matter which one that we check the size of, because they're all going to be the same size. All right, how do we print these things out then? Cout. Okay, angle name. Angle age. And then square brackets I. Angle and then a space. Angle shoe. Square brackets I. Pardon? Oh, your names, yeah. Sorry. Okay, so here we go. We should have loaded things, and now we're printing them out to make sure that they loaded correctly. Yes? Ah, thank you. It's like having a distributed compiler right in front of me. It just does error checking. Anything else I messed up? All right, let's see if that still compiles. It does, and if we run it, it prints out the data that looks like the data in the file, except the header line is missing, which is good because that's what we wanted, right? Header lines are for humans most of the time. Great. So now we printed out the vectors and checked them. Let's say we wanted to do, yes? Yeah, so I will prove to you that it works. So all of these vectors, age, name, and shoe, should be the same size. They should have the same number of entries in them. And the reason is because every time we put something in one of them, we put them in all of them. Okay, so every single time we add something to one vector, we add it to all the vectors, so they will always be the same size. So it doesn't matter right here which one we put in there. So I changed name to age. I'll compile it. I'll run it. It's the same. And I could do the same with shoe, and it's the same. And the reason is because the way we're storing the data is we have these vectors, and for each person, there'll be one entry in each vector. So every time we add a person, we will add one entry to every single vector, and the vectors will always be the same size. All right, so let's say we want to do some computation. Let's say we want to print out the average shoe size. Would you rather do average age or rather average shoe size? I'll give you an exciting choice here. How many of you want age? How many of you want shoe size? How many of you just want to go home? How many of you want to be set on fire? I figure as long as nobody wants to be set on fire, I'm doing my job, so pretty low standards. So let's say we want to do the average. What won that? I didn't even count. Shoe size? Let's say we want to do the average shoe size. We have a vector, and it's full of numbers. How do we take the average of those numbers? How do we average something? Exactly. We add them all together, and we divide by the number of things in them. Okay? So if we want to add together all the elements that are in the shoe vector, how do we do that? Yeah. Yep. So we declare a variable, shoe total, and now we have to loop over things. What are we going to loop over? First of all, in order to average these, we have to look at every single element in the shoe vector. How do we look at every element in the shoe vector? For loop. Yes. Anytime I say every element in a vector, you should say. All right. So it's super common to do this way. So, in fact, I'm just going to cheat and cut and paste this loop because I'm lazy. And I'm going to make it shoe.size because that's kind of funny. For me. Okay, so here's our loop for int I equals 0. Wrong loop. Int, we declare this shoe total. We say int I equals 0, I less than shoe.size, I plus plus. We say shoe total plus equals shoe square brackets I. And what this is going to do is it's going to say, okay, I start with the number 0. I go from this loop from 0 to however many things we have in there minus 1, which is the 0th element, first element, second. So it's looking at every element in there. Each time, add that to the total. So it runs down the column and totals everything up. Yes, sir? Yes, it should be. All right. Now that I've corrected that small error, everybody happy with this? Now, to compute the average, how do we compute the average? C out shoe total. Oh, by the way, I totally screwed up. It shouldn't be int shoe total, it should be float because it's floating point numbers. So shoe total divided by shoe.size. No, I don't have to change that because the int I refers to the number of elements in the vector, and we are going to have an integer number of those. There are no floating point numbers. But I forgot that shoe size has halves and stuff in it. Yes, sir? No, you don't have to. The compiler would do that. Typically, typically that's just nice to do so that when other programmers look at it, they can see that it's a floating point. So here's the deal. I'm a bad person. I don't know if you've noticed that. I'm trying to teach you to do things the right way, but then when I demonstrate, I do them the wrong way because I'm a bad and lazy person. Okay. That doesn't mean that you shouldn't do them the right way. I've done that a lot today, haven't I? Yeah, I suck. Sorry. All right, so we have our total. We're going to iterate across. We're going to look at every element of the shoe vector, add it to the total, and we're done. We're going to compute the average by dividing the total by the number of elements that we looked at, which is the dot size. Everybody good? So let's just take a quick look at this. So we have a shoe size, 8.5, 9.5, 10, 6.5, 7. I have no idea what value that's going to come up with. Anybody want to guess what the average of that is? Did you already add it up? You already ran it. Oh, okay. All right, so we'll compile it, and we will run it, and it says 9.21429. So the average shoe size is slightly over a size 9 in this completely contrived example I made up, from which we can draw a lot of conclusions. Yes, sir. Mhm. Yes, absolutely. So if for some reason things went wrong and we were trying to average over a vector that was empty, what would shoe.size be if it was empty? And what happens when you, on a computer when you divide by 0? It is the end of the world. That's at least the end of the program. Right? You will get a bad result. So this example doesn't take into account checking that you should do, particularly when you're doing division to make sure you're not dividing by 0. And in fact, completely geeky story aside, back in the day, a long time ago, back when I was your age, which is funny to me, there was a computer security vulnerability where if you had a program in the computer, if somebody divided by 0, they could take control over the computer and get administrative access to it, even if they weren't administrator before, just by dividing by 0, which is a pretty cool trick. So, so it's good to do error checking like that. And if you're wondering how the hell that works, then you need to stay in computer science and take my security class in like 2 years, and I'll show you. All right. Everybody happy with this so far? Everybody see the relevance to the project? All right, so the only other thing we need to do is be able to find one particular thing. So let's say, for example, that out of all these subjects or all these people in here, we wanted to find the data for one particular person. How would we find all the data for that one person? Well, first we'd have to ask what person we wanted to find, right? So let's say I gave you the name of a person, and I wanted you to go through and find that person's data. How would you do that? Yeah?
Could we do a for loop where we have it run until we find the name, which is Boolean true equal to?
Yeah, that's exactly it. What we'd have to do is, given a name, we would have to loop through all the names and look at it until we found, either we found the name we were looking for, or we realized it wasn't there. Does that make sense? Everybody with me? So then once we had that name, once we knew where it was, we could then get the data from the other vectors given the correct index into the vector. So if I said, where's all the data for Sam? You'd go, oh, Sam. You'd start looking at the vector and you go, oh, I found Sam right away here in the first place. So I know that while the name's here, Sam's age is over here and Sam's shoe size is over there. And you could retrieve all of those. Does that algorithm make sense? So our algorithm is given a name, look through the vectors of names until you either find the name or you realize it's not there, at which point you know which other vectors to pull the data out of. Okay? Everybody kind of with me on that? So here I'm going to outline our algorithm. Input a name, loop through the name vector to see if we can find it. If we do, output the name, age, and shoe size. If we don't, what do you want to do if we don't find it? Yeah, we can say output something like name not found. Okay, so this is our algorithm for finding something. So let's just code this up really quick. So what we need is we need a string name to find, which is the name we're looking for. We can see out and say enter a name to find. Do we want to use cin or do we want to use getLine for this? Okay, in this case it doesn't really matter that much, and the reason is because I've guaranteed you in the file that there's only one name, right? There's like a single name. So either will work. Which do you want to use? I would personally use getLine just because that's what I would do. How about I use getLine? All right, get line name defined. Now, so we've input a name. We need to loop through the name vector to see if we can find it. When I say loop through a vector, what loop do we use? All right, there's our loop. And what are we going to do at each iteration of the loop? Yeah.
So we're going to take that component of the vector.
Mm-hmm.
We're going to check if it's equals to name defined.
Absolutely. That's exactly what we're going to do. So we're going to say, if the name in the slot we are currently looking at, name.I, is it equal to, which is equal rather than single equal, name defined. Now that we've found it, what do we do? See out what? Anything else? And what do we put in this age square bracket here? Why? I mean, why do we put I in there, not the letter? Because every person is going to be in the same row in each vector. All right. Is that good? Do we want to know? So here's my question. How do we keep track? This will print something out if we've found it. Okay? How do we keep track after we're done if we found what we were looking for or not? Yes, sir. Think so? You're sort of right. What happens if the name's in the last slot, though? Like, I think if name is in the last slot, that will fail because it'll say it wasn't found, even though it was found in the last slot, because the I will be at the right value. Does that make sense? Okay. Oh, yeah, you're right, I think. Let's try it and see. So, yeah. So here's how I would do it. There's different ways to do it, and I think the way that you talked about it is correct. The only problem is that I is a loop variable and it won't exist afterwards, so we'd have to declare outside of the loop. But here's what I normally do. I normally create a Boolean variable. Gosh, is C plus a bool or Boolean? It's bool, okay. So I normally create a Boolean variable that keeps track of whether we've found things or not. And what we do is once we find something, you set it equal to true, and that means you found it. And then after the loop terminates, you say if not found, because we didn't find it. Yes?
So when you say if not found, is that just taking found and setting it to false?
So what I'm saying, here's how this part works. So everybody understands how once we match it, we print out the data, right? So the question is, what if we don't match anything? Yes? Yeah? Yes. I can show you that. Right now, this check we're doing is actually case sensitive. It has to match exactly. There's stuff you can do to get around that, but for the purpose of the project, just assume the case is going to be correct, like it is case sensitive. To make it case insensitive, most strings have a method which is like to upper or to lower, where you can make the whole string uppercase or lowercase, and you do that before you compare it. But we can do that in a sec if you want. I just have to look up the string function because I haven't used it in C++ recently. Okay, so here's what we're saying. Enter a name. read the name in, loop over every element of the vector, and if you find the name, print out the name and the corresponding age and shoe size. All right, that's part of it. The other part we need to do is actually keep track of whether we found something or not. So when I start, I say found is false. And the reason I do that is because we haven't found anything yet, have we? So when I initialize this variable, I say we haven't found anything yet, so found is false. If we find something, what I do is I set found equal to true, because now we have found a match of what we're looking for. Right? After the loop terminates, when it's all done, we can say if not found. If found is true, what does not found make it? False. And so it won't do this, but if found is still false, when we reach here, not false is. So not false will cause it to print out we didn't find anything. I think I just messed that explanation up. Yes? Sure. Yeah. There we go. How's that? So this is the message that we have to print out in case we don't find what the user asked for. And so we want to keep track of whether we found or not. So if this loop runs and none of the name matches, this will never print out. Found will never be set to true. So when the loop is all done and it goes on to the next statement, it'll say is found false, and it'll go, oh, that never changed. It's still false up here, and it'll print out was not found.
But what if, so if you're using name instead?
They're equivalent, yeah.
Yeah, but I don't think I see how they're equivalent, because if you didn't find.
Okay. So the question is here. I'm gonna put one of these in comments, and we'll write it both ways, right? So found equally false, and not found. So if found is equal to false, let's presume let's assume that we set this to false and we never found anything. So we exit the loop and we are right here. What is found equal to? So if found is equal to false, is that true? How about what is found equal to right here? And what is not false? So these two are going to be equivalent. It is, trust me. But if it's true up here, so say we found something and it's true. True, is true equal to false? And what is not, if this found is true, what does found get replaced by? No. If found is true, what does found get replaced by right here? And what is not true? And if it's false, does it do this loop? No. If it's false, we don't do the if statement. Those two things are equivalent, trust me. So, all right. How's everybody doing today? How many of y'all are happy? Good. I like happy students make me happy. All right, let's actually see if this works. Okay, we have a bunch of names. We have a shoe size. What name do we want to find? Sam? There was Sam. We'll run the program again. There's all names. What name do we want to find? I heard somebody say Rico. Lizbeth. Whoop, did I type it wrong? Lizabeth. See? There you go. I forgot the A, so they were not found. All right. Yes? Say again? One more time with the question. I don't quite understand your question. Oh yeah. You could put a while loop around that, and you could just do it over and over again as much as you wanted. So we just did it once. So yeah. Then you would have to loop over the age vector, and instead of looking for name equal to thing, you would look for age equal to thing. So if we wanted to search for everybody who is like 19 years old, then in our program, in this loop, instead of looking for a name, we would look for age, like we do age square brackets I equals age to find. So it is identical. No matter which one of these things you do, whether you're looking for name, age, or shoe size, the process is going to be identical. You just essentially swap out name for age or shoe size. Absolutely. Once you find the right I, once you find the right I indicates the row that that subject's in each one of these vectors. Once you find the right one, you can just print it out of all of them. So it's identical. Whether you're looking for age or name or whatever you're looking for is exactly the same. So I think in the project I asked you for subject ID, right? This is essentially what you need to do for subject ID. But there's also a more complex one where I ask you to average things within a particular age range. And for that, you have to look at the age and decide based on the age whether or not to add it to your total or not. So it's a little more complicated. But these pieces are kind of like the basic parts of the project that you need. And in fact, I normally don't give you all this much help, but I felt like it today. I don't know why. Because I'm in a good mood or something. All right, other questions? This is very relevant to a bunch of different pieces of the project. Yes, sir. So he's asking if you wanted to sort the names alphabetically, how would you do that? And the answer is more complicated than I would like to explain in this class. How's that? It'll be easier to do later in the semester. Does that make sense? Why? Is mine sorted? Oh. Yeah, I don't remember how I did that. I was just messing around when I was writing it. So, no, yours doesn't have to be sorted. But if you would like a challenge for this project, because it hasn't been challenging enough for you, the challenge for it is to do it so it's all sorted. Okay. Start up with this person class stuff. I'll tell you what. So, Eamon, is that how you say your name? Eamon? Okay. He's programmed before and he knows where this is going, and it's frustrating for him because this way is dumb. Okay? It's dumb, but it teaches you how to use vectors and it teaches you how to iterate over vectors and stuff without having to have all the additional baggage of when we package all this stuff together, figuring out how to do that at the same time. Okay? So for you, it seems silly. For other people who haven't programmed, there is actually a reason we're doing it this way. And later, for Project 4, I'm just going to tell you what Project 4 is right now. Are you ready? It's this project over again, done in a different way. Okay? That makes more sense. And you'll already have all the mechanics for the loops and stuff, and then you can just focus on how we're going to combine age, name, and shoe size into one thing that we can deal with individually.